Hello, thank you for joining me. My name is Christian DeLucia, and today's video is on data management basics. The purpose of the video is to provide a brief overview of some important data management operations. I want to give a caveat that data management is a vast topic. These slides are purposely limited, and throughout the slides, I'm going to refer to SurveyMonkey and SPSS as two specific platforms, but many of the procedures I discuss are generic and can be applied regardless of the software you're using. Okay, so a situation that people find themselves in often is trying to get data from a platform like SurveyMonkey into a platform like SPSS where they can do some analyses. And so even though I sort of frame the slides in this way, again, the topics are general and can also be applied to circumstances where students or researchers are interested in doing secondary data analyses and they gain access to an existing data file and they want to make some changes to the data file or compute some new variables or rename some items. Okay. Now, typically, considering starting from a platform like SurveyMonkey and outputting a data file, typically we'll get a data file that looks like the one in the top left-hand corner here, where SurveyMonkey will use an algorithm to both name the items and also to code the response options. And typically, we might want to rename the items to have names that are a little bit more consistent or more meaningful with the constructs we're investigating. We might also need to alter the response option, so we can take a look at how we do that. Before, though, I want to talk about two data file orientations that are more common in the social sciences. The first is referred to as a wide data file, and the second, a long data file. Here's a picture of a wide data file. We've got 5 respondents in this hypothetical data file assessed on 3 depression items on 2 occasions. So in these wide data files, which is far and away the more typical configuration that we see in the social sciences, each respondent or case occupies a single row only on the data file. So all of the information tied to that case or respondent will be reflected on that one particular row in the data file. In contrast, as we shift to a long data file, we've got respondents can occupy 1 or more rows on these long data files. And so in this case, we see that 4 of our 5 IDs are present on 2 rows. We've got 3 depression items. We've got 2 times of assessment. We think about a baseline and discharge, say, for example. Okay. Now, the kinds of analyses we're doing and the software we're using might dictate which structure we need the data in. And SPSS has procedures to go from wide data files to long data files and from long data files back to wide data files. So a couple of essential database items. If possible, use a numeric ID variable to code respondents. The ID variable is really important. It acts as a unique identifier, and that can be really helpful if you're interested in flagging observations with anomalous responses, or if you're in a situation where you have multiple data files that are tied to the same individuals and you want to merge those data files. You need the unique identifier to facilitate a seamless merge. If you're surveying people, ask for their date of birth. Make sure that date of survey completion is captured. SurveyMonkey does this automatically. And also collect any other information related to survey completion that is necessary for the study you're doing. Sometimes time of day is important, say, for example, so you want to make sure to capture that. So next I'm going to talk about how to name and code response options. And so here we're looking at 3 GAD7 items that are, from the SurveyMonkey platform. GAD-7 is a commonly used brief measure of general anxiety. And as I mentioned before, SurveyMonkey will use an algorithm to name the survey items and to code the responses when it outputs the SPSS data file. And so typically we'll use some data management operations to alter the item names and the response options. Over the years, I've learned that either a 4 or 3 component item name is usually sufficient. People have different sort of preferences for this, but I give an example of the 4 components here, where one of the components is a reporter. And here we're going to say, okay, we're going to use C for child report, P for parent report. A second component is the wave of assessment. This assumes that we're collecting data over multiple assessment occasions, which is quite common in the social sciences. The third element is the construct tag. And so we're going to use DEP, short for the word depression, assuming that we've got some depression items we're assessing. And then we're going to want an item number that essentially codes the serial position of the item in the survey. And so if we have 3 depression items, we'll have item numbers ranging from 1 through 3. On this slide, I show a table of these various elements, and our ultimate item names are highlighted in green, and we could see that the item names are a combination of these components, the reported tag, the wave tag, and the item number in this case. And also, it's not present in the table, but we've got the construct tag as the 4th component. So P1 DEP1 is parent report at time 1 for the first depression item. And then you could, all of the other items have a similar interpretation. Okay, now I want to shift to talking about response options and provide a few guidelines. Coding response options, when we're talking about that, we're typically talking about assigning numeric values to various response options. Typically, when we're running analyses, that's the way our variables are coded. And so I've got one of the hypothetical GAD-7 items down below, and this is what the respondent sees as they're completing the survey. So the item is feeling nervous, anxious, or on edge, and then the respondent selects from the 5 response options: not at all, several days, over half the days, nearly every day, or I choose not to respond. So in this scenario, we might want to code the not at all responses with a 0, the several day responses with a 1, so on and so forth, up to the I choose not to respond with the numeric code 4. Okay, so a couple of additional guidelines: code responses such that higher scores reflect higher levels of the construct. That just means if a person is higher on a depression subscale relative to someone else, it just means they're reporting a higher level of depression symptomatology. Okay, if you're using a normed measure, use the same response options used by the measure developers. And if you do that, your sums and means will be comparable. And so any of the normative data that's available to you, you'll be able to use to qualitatively appraise your results. Use 0, 1 for dichotomous items. Dichotomous items are often used to reflect the presence or absence of some characteristic like a diagnosis. And so we'll code the absence of a diagnosis as 0, the presence of a diagnosis as 1. And I typically start my response options with 0 if 0 is relevant. So if the low end of the response scale suggests, for example, someone has used marijuana 0 times in the prior 90 days or not at all in the prior 90 days, I'll usually start those response scales with a 0 and go on from there. Otherwise, if you don't really have a meaningful 0 point, it's perfectly fine to start the response options with 1 and go up from there. So next, I want to talk about a couple of Operations, we've already talked about naming, and we've talked about coming up with a way to code response options. And now I'm going to talk about those procedures and also some additional procedures like declaration of missing values, computing sums, means, age, but I'm going to embed that discussion in the context of SPSS software. SPSS is a software package used for statistical analyses. It's commonly used in the social sciences, and so I'm going to present some of the command syntax to perform some of these basic data management operations. So here's a hypothetical data file where we've got 10 IDs and we've got 10 variables reflected here: ID, date of birth, date of assessment, and then the seven GAD 7 items. And they start out with these sort of funny looking names like Q0057 underscore 0001. Again, that naming convention came from the SurveyMonkey algorithm, and we're going to alter that. In SPSS, there are two ways to view the data file. What we're looking at here is referred to as the data view, and in this view, we see the full data table, we see everybody's responses, so on and so forth. The other view is referred to as a variable view, which is what we're looking at here. In the variable view, we get to see the characteristics associated with the variables. For example, DOB and DOA are date variables. So under the column type, we can see that date is selected there. The other variables are numeric. SurveyMonkey will typically dump the item that the respondent sees in the variable label column. That's not always the case, but is often the case given the structure of the question in SurveyMonkey. And so in this case, it put feeling nervous, anxious, or on edge in the variable label column, and that helps us link the responses to, the responses in the database to the items that we're working with from the survey, okay? And also, if we see two other columns that are relevant are values, and the missing column refers to missing values. And so on the next slide, we're going to take a look at the values options there. So if I just clicked on values for our first GAD7 item, and this is what we see. This just tells us that SPSS coded these response options ranging from not at all to I choose not to respond, from 0 to 4, which is the coding system we saw on a prior slide, okay? So now typically, if we ask SPSS for descriptives or frequencies, if there are value labels associated with the variable, SPSS will default to printing the value labels in the output or results window. And so it's sometimes you want to know the numeric codes. And usually when I create my own value labels, I embed the numeric code within the label because I often want to act on those numeric codes. And so in this case, if we see not at all in a frequency table, we know from looking at this values table that that not at all is coded numerically in the data file with a 0. Okay, now I'm going to talk about naming or renaming items in SPSS, and there are lots of different ways you can do this. I typically use the compute or the recode procedure, although there is an actual rename procedure within SPSS. And so here's an example of renaming a series of variables using a recode statement. And I'm not going to get into all the details of the syntax. These next few slides are going to assume that you have some basic knowledge of syntax. If you're used to doing these kinds of procedures using point and click operations, what's happening as you're using the point and click interfaces, SPSS is generating command syntax behind the scenes. And so in this case, I just wrote out the syntax myself. So here I say that the syntax has 6 elements. Recode is the first element. It invokes the procedure Q0057 up to, Q00580003 identifies the original items to be recoded. Low through high equals copy tells SPSS to copy original response options to the new items. The keyword into tells SPSS to create some new items. And then GAD1 to GAD7 tells SPSS what item names to assign the new items. The period at the end of the statement signifies the end of the procedure. So essentially in this recode statement, we tell SPSS, look up these original items, copy the responses from those original items into these new items that we want named GAD1 to GAD7. Okay. And then my final point on this slide just says, when using recode statements, I always generate a new set of items to avoid possible ambiguities about the coding of response options. That's a little bit more relevant when you're altering the response options, like in the case of a reverse scoring procedure. But I feel like it's always a little less ambiguous when you create a new set of items. Now, this is something that often confuses students who are less familiar with SPSS. Sometimes when we have a procedure like our recode procedure, if we execute it, SPSS will add the new items to the data file, but it will not populate the responses yet. There are a couple ways we can get it to populate the responses. One is to execute the syntax. Literally, we could type the word execute, period, highlight it, click the run button, and SPSS will populate the values in the data table for us. The other way we can do it is just by calling these items into a procedure like a frequency procedure or a descriptives procedure. Once we do that, SPSS will populate the values in the data table, and our data table will now look like this, where we see the values are present there. Okay. Now, in this first example, we did not need to alter the response options, but if needed, we could have done that using the recode statement. And so I'm going to show you how to do that by making the assumption that the final GAD7 item required reverse scoring. And typically, we will reverse score items if the question stem is worded in the opposite direction of the other questions on the subscale. We will need to flag that item and flip its response scale essentially so that it is operating in the same direction as the other items on the measure. So here's a batch of syntax using recode statements that would achieve that for us. The first recode statement is the same as from a couple slides back. And now we're going to say, okay, use this recode to act on the first 6 items and just copy the response options into these new items, GAD.1 to GAD.6. And then the second recode statement gives the original item in question. It's Q0058_0003. And then we've got a series of parentheses. In each one, we're going to take the original response option and convert it to a new response option. So we're going to take the zeros, make them 3s, take the 1s, make them 2s, so on and so forth. Okay. And then we're going to convert or create this new variable or item GAD.7, okay? And so this syntax will achieve that goal of flipping the response scale on that final item. And if you run a reliability procedure or you come across some odd results where you've got, an item that is strongly negatively correlated with the other items on your scale. It might be a symptom that you missed a reverse scoring operation. So just be mindful of that as you're working with your database to flag all of the items you think need to be reverse scored, and then go ahead and use a procedure to perform that operation. Another thing we often want to do when we're working with data files is we want to declare missing values. So SPSS will treat those values differently than they treat valid response options. Now, in the hypothetical items we're working with, we had a response that respondents could select. I choose not to respond. Typically, when I collect data on platforms like SurveyMonkey, I'll require respondents to provide a response to every item on every page of the survey, because we want them to not get in the habit of skipping questions or several pages at a time just to get to the end of the survey. However, we want the participants to have the flexibility to select out of responding to an item if it's a little too sensitive or they don't like the way it's worded. And so a way to balance those two objectives is to give them some kind of response, like an I choose not to respond option. Now, on the data management side, however, we're going to want to code such responses as missing values, because we're not going to want that numeric code to contribute to a sum or a mean, for example, for a set of items with those kinds of response options. So we could achieve that very easily in SPSS using one line of syntax, missing values, GAD1 to GAD7, parens, 4, period. The syntax has 4 elements. Missing values invokes the procedure. GAD1 to GAD7 identifies the items to act on. Parentheses 4 tells SPSS which response to code is missing. Period at the end of statement terminates the procedure. No execute statement is necessary, which means as soon as we highlight this line of syntax and click the run button, it will take effect. Now, if we execute a missing values procedure and we look back at the variable view of our data file and we look at the missing column, we'll see that for GAD 1 through 7, the 4 is now reflected there as a missing value response, whereas for the original items with the original SurveyMonkey names, like Q0057 on the score 0001, we don't have any missing value codes there because we didn't put them on the data file, because we're going to ultimately, in a situation like this, we save out a smaller data file with the newly computed variables. Okay, on the next couple slides, I make a note of a subtle issue, but something I wanted to point out. If you're using a platform like SurveyMonkey that allows you to embed some skip logic, which is always nice, because you want to, when you're surveying participants, you want to sort of keep the response burden at a minimum. And one way you can do that, I'm a substance use researcher, and so typically when my surveys will ask people questions about their substance use, and typically for lots of different substances. And so the example I have here is we might have an initial question that asks someone, have you ever used marijuana? And then their responses will be no or yes. And if their answer is no, we're going to skip them out of the rest of the questions related to marijuana use. And we're going to move them, we're going to skip them over to the next substance. Whereas if they answer yes, then we might ask them a series of additional questions. One of those questions might be a question like, how often have you used marijuana in the prior 90 days? Now, typically in SurveyMonkey, when we use this kind of skip logic, what happens is when the data file is output, the participant will be coded as system missing in the SPSS data file. There are essentially there are two ways to think of missing data in the SPSS environment. System missing, you know, comes from a procedure like this where SPSS doesn't have an observation for the person in question. And so it will put a period in the data table in that relevant cell. The other kind of missing data is the type I was just talking about, which is typically referred to as user-defined missing data, where we tell SPSS, okay, let's take the responses of 4 and code them as missing. Now, so in this case, however, if we want to run a frequency on prior 90-day marijuana use, everyone who skipped the marijuana questions because they reported no lifetime use will be coded as a missing response on those subsequent questions. However, they're not really missing. We know, for example, that if they've never used marijuana, that their frequency of marijuana use in the prior 90 days is 0 or never. And so we're going to want to alter that system missing response and give that person a valid response of 0 so they remain in the analysis of those kinds of questions. That's a subtle point, but one worth making. Okay, next I want to talk about computing sums, means, and ages using some SPSS syntax. SPSS has a compute procedure that is pretty flexible that we'll talk about here. And so in this first instance, we're computing the sum of the 7 GAD items. And so here is our syntax. It's got 5 elements. Compute invokes the procedure. GAD sum names the new item to be computed. Equals sum.6 tells SPSS to return a valid response for GAD sum if the respondent has valid observations on at least 6 of 7 GAD items. So this is a way of controlling missing data. And in this case, we're requiring the respondent to have valid observations on the vast majority of the items that are going to contribute to the sum. GAD1 to GAD7 tells SPSS which items to base the sum on, and the period at the end terminates the procedure. For compute statements, executes are necessary to get SPSS to immediately populate the response options in the data table. Okay, so now we're going to talk about computing a mean or an average of the 7 GAD items. The syntax looks quite similar. Compute invokes the procedure. GAD mean names the new item to be computed. Mean.6 tells SPSS to return a valid response for GAD mean if respondent has valid observations on 6 of the 7 items. GAD1 to 7 tells SPSS which items to base the mean on. The period at the end terminates the procedure. And again, the execute statement is necessary. And the last thing I want to talk about is, at least in the compute realm, is computing age in years. SPSS has a number of operations that are pretty powerful, working with date and time variables. And one of those operations or procedures is the ctime.days procedure. And essentially ctime.days allows us to take the difference in days between two dates. And in our case, our two dates are going to be DOA for date of assessment and DOB for date of birth. And so this is what the age syntax looks like. It's a little more formidable than the prior lines of syntax we were looking at, but it's pretty simple if you break it down. So compute invokes the procedure. Age names the new item to be computed. Equals ctime.days, DOA minus DOB, divided by 365.25 tells SPSS to return the difference in days between DOA and DOB and then convert it to years by dividing that difference by 365.25. The 0.25 is just to account for leap years. The period at the end terminates the procedure, and consistent with all of the compute statements we've seen already, the execute statement is necessary. Finally, I want to talk about using SPSS to save out Z or standardized scores. Z scores are useful for lots of different applications. The formula for a Z score, if you don't remember, is X minus the mean of X divided by the standard deviation of X, where X is an individual score. And SPSS will save out Z scores from the descriptives procedure. There are a couple different ways you can do that. Here's one way where we just have descriptives invokes the procedure. Age is the original variable that we're going to get the descriptives on. And then in parens, we have Z age, which is essentially the name of the standard score that SPSS is going to add to the data file for us. And then once that Z score for age is on the data file, we can look at it or manipulate it in ways that we would with any other variable. Okay, finally, I want to give you some additional resources. Obviously, you can Google SPSS to figure out how to purchase it, and you could download their command syntax manual. It's available in PDF form. There's a great resource, Reynolds SPSS tools, that has lots of syntax scripts and so on and so forth. And it's something I've used over the years, and I think it ranges from it's got applications that are more relevant for beginners, and then it's got applications that are more relevant for much more advanced SPSS users. For whatever reason, when I was creating these slides, I couldn't get the web page to work. But I took a screenshot of what came up in Google, and that's what we're looking at here. Another great resource is UCLA has lots of stats-related resources, and this is a web page here that is specific to some SPSS modules, and so I figured I would include that in this slide set. I hope you learned something from thinking about these data management operations, and thanks for checking out this video. Take care.